Okay, here we go. Exercise 2. You guys know there's only so many formulas they're going to use in this. So just depending on what they give us, it's only out of like, I think 4. And 2 of them are pretty much the same formula rearranged. So really there's just 3. So that's going to be a piece of cake. So here we go. Exercise 2. Gary Stewart of Reading, Ohio, Reading's the city, set a pogo stick record in 1990 by jumping 177,737 times. That is a lot of pogoing. A. If the pogo stick he used had a force constant of 6,000 newtons per meter and was compressed 0.12 meters on each jump, what force must Gary have exerted on the pogo stick upon each jump? And then push answer B, what we're looking for. What force would be exerted back up on Gary each jump? Okay, so here we go. Let us begin. So first thing we're going to do, the thing we always do at the beginning, is we are going to highlight. Right? So I'm going to highlight the things that I think are important. The year is not important. This is not important, even though it's cool. So the force constant, that's important. 6,000 newtons per meter. Let's highlight that. And the compression. So compression is how much something is like squished together. So essentially, if we think about it, that's just distance, right? Or displacement. So let's highlight this. So 0.12 meters on each jump, right? So again, guess method, whatever method you want to call it. What do I know? I know the force constant, and if I remember my formula, the force constant is K. That's the thing, right? And it was 6,000 newtons per meter. So we got that. And we also have this, which is distance, and in our formula it was X, is 0.12 meters. So not even a little bit more than like 1/10 of a meter, right? So that's our, what do we have? What do we need to know? Well, what's it asking us? Let's highlight that. Actually, no, let's circle that. Force. So our force is what we don't know, right? So here we go. So we got our half. We got our what do we need? And let's do our formula. So if you remember our formula, it is force equals the restoring force, which is what? It's K, right? K times the displacement. So let's plug in everything we know. It should be a piece of cake, in all honesty. Bam. Rewrite it again, because remember, we just got to rewrite stuff over and over. Don't skip steps. Just because you know it, rewrite it again. Okay? Until you don't have to think. So force equals 6,000 times 0.12. What I'm going to do is I'm going to put it in parentheses, 0.12. We know it's in parentheses side by side, so that means multiply, right? So, do that in your calculator. Boop, 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 boop. So, what we got is, you should get 720 newtons. That's our force. So our force is 720 newtons. So we figured out that the force that he exerted on the pogo stick each jump was 720 newtons. So if we bring our paper up a little bit so we can see this, we know that answer A is 720 newtons, right? So now let's look at answer B. What force must be exerted back up on Gary each time he went up? So no, he pogoed down, and then the force that pogoed him back up. So this is kind of sort of like that deal like one of Newton's laws where it's like action equal opposite reaction. Force in, force out. So if I punch a brick wall, the brick wall is going to punch me back in the hand, right? So with that being said, let's look back to answer number B. So what force would be exerted back up on Gary each time he went up? So if we flip back to our page here, let's look right here. Keep in mind, now we're talking about the restoring force, right? Our restoring force is F, which is what we solved for. F equals our restoring force. Keep in mind that this is the force required to restore a point back to its original position. The force that acts to move the spring away from the equilibrium position is equal in magnitude to the restoring force, but in opposite direction. In other words, the force pushing down, that's pushing it out of that equilibrium, is equal to the force wanting to push it back. So if you have our spring, so if he has his pogo stick, let's see, this is going to be my pogo stick. Sorry, Gary, you are not going to make it on my pogo stick. And then remember, it's got a spring, and then it's got its like little landing thing, right? So the force he applies, 720 newtons, when he pogos down, and it's crunched down. Back my pogo stick. How it's like crunched in a little bit. This same force should be forcing it up. So let's read this one more time just so we're clear. Keep in mind, so blah, 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 restoring force. What's the restoring force? The force that pulls back and attempts to restore the spring to equilibrium. So natural balance, like a relaxed state. Keep in mind that this force is, that the force required to restore a point back to its original position, the force acts to move the spring away. The force that acts to move the spring away from the equilibrium position is equal in magnitude to the restoring force. So the force that acts to move it back, this force right here, should be equal to the force that brought it out to begin with. I.e., your answer B should be the same, 720 newtons. Piece of cake. All right, guys, good job. We'll do one more for the other equation, and then you guys can do the rest. If you don't need help, if you don't need these videos, just skip them. Just do it on your own. If you need help, look at the videos for what you need. Do your best to do it on your own, because it feels way better when you get it on your own than when you get walked through. But either way is fine.